Have you ever wondered how the number of calories on the back of food packages is determined? This is done by bomb calorimetry. But before we can fully understand this, we need to define a calorie. A calorie is the scientific unit that is defined as the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. In the United States, food packaging lists calories, but these food calories are actually kilocalories, or 1,000 calories. In most other countries, you will see food packaging with kcals listed. Kcal is the abbreviation for kilocalorie. Food has calories because our bodies process the food in a chemical reaction called combustion that breaks down the food and gives off heat. It's this heat energy or calories that our body uses or stores as energy to keep us going. Many other chemical reactions give off heat as well. These are exothermic reactions. Reactions that take in heat from the surroundings are called endothermic reactions. A bomb calorimeter is a device that is designed to measure the amount of heat that is given off or taken in by a reaction. It's designed to be isolated from the surroundings, meaning that no heat can leave or enter the device. In order to accomplish this, the outside wall of the calorimeter is a vacuum-sealed wall, similar to an insulated mug you might carry coffee in. Inside the calorimeter is a vessel in which the reaction occurs surrounded by a water bath. The temperature of the water bath can be monitored via a thermometer. When a reaction takes place in the calorimeter, the temperature of the water bath changes. If an exothermic reaction occurs, the water bath temperature goes up. If an endothermic reaction occurs, the water bath temperature goes down. In an ideal calorimeter, all the heat exchange would take place with the water. However, in real life, the materials from the calorimeter itself, the stainless steel, thermometer, etc., exchange heat with the system as well. We can correct for this by using a heat capacity for the calorimeter in our calculations. Because all the heat is exchanged inside the calorimeter, we can set the total heat to 0. We have 3 terms for the 3 parts of our calorimeter: the calorimeter itself, the water bath, and the chemical reaction, which you can see labeled in the equation on your screen right now. Substituting the equations for the heat of the water and the heat of the calorimeter, we get this much more detailed equation that's appearing on your screen right now. Looking at this equation, you should note that the term for Qcal has no mass. This is because it is assumed that the mass of the calorimeter is constant and therefore can be included in Ccal. Also note that delta T should always be calculated as Tf, final temp, minus Ti, initial temp. This means that if the temperature of the object goes down, delta T will be negative. Cp is the specific heat capacity for water and is 1 calorie per gram degree Celsius. Looking at the equation now appearing on your screen, you can see how we solve for Q reaction. Let's take a look at an example. First, here's our problem. A 30-gram sample of potato chips is combusted in a bomb calorimeter, raising the temperature of a 10-kilogram water bath from 25 degrees Celsius to 36 degrees Celsius. The Ccal of this calorimeter is 909 calories per degree Celsius. How many calories are in this serving of potato chips? Now here's our solution. We need to start with the equation for Q reaction that we derived a second ago. In this problem, Ccal is given. M is the mass of the water, which we usually express in grams, and delta T is the same for both the water bath and the calorimeter. We can assume that they started and ended at the same temperature. This means that 30 grams is, for now, extra information that isn't needed. It's there because once Q is known, the number of calories for any size sample can be determined. Inserting this information into the previous equation, we get this lengthy equation. 909 calories per degree Celsius times 11 degrees Celsius plus 10,000 grams times 1 calorie per g degrees Celsius times 11 degrees Celsius. The result, all things being negative in the equation, is negative 120,000 calories. The negative sign on Q reaction means that the reaction is exothermic. If we had measured an endothermic reaction in the bomb calorimeter, Q reaction would be positive, and heat would be added to the reaction. So, a 30-gram sample of potato chips gives off 120,000 calories, or 120 kcals. In the United States, remember, this would be written on a package as 120 calories because food calories are actually kilocalories. The number of calories per gram would be calculated by dividing the number obtained by 30 grams. Then the number of calories of any size sample could be calculated by simple division and multiplication. As you can see, 120,000 calories divided by 30 grams equals 4,000 calories per gram. Let's take a few moments to review what we've learned about bomb calorimeters. First, it's important to remember that a calorie is the scientific unit that is defined as the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. A bomb calorimeter is a device that measures the heat given off or taken in by a reaction. Inside the calorimeter is a vessel in which the reaction occurs surrounded by a water bath. The temperature of the water bath can be monitored by a thermometer. Both endothermic and exothermic reactions can be run within a bomb calorimeter, and we can use this general equation that's appeared on your screen to describe the behavior in calorimetry. Note that there will be additional terms if multi-step reactions are occurring or there are other components within the calorimeter. If the calorimeter is considered ideal, C-cal will be 0, eliminating this term.